Good day, everyone. In this video, we are going to learn ellipses. And I would like to give my and extend my gratitude to www.northlandprep.org for the resources of the content in this PowerPoint. Let's start. So, geometry of an ellipse. By definition, an ellipse is the set of all points in a plane whose distances from two fixed points in the plane have a constant sum. The fixed points are the foci of the ellipse. The line through the foci is the focal axis. The point on the focal axis midway between the foci is the center. The points where the ellipse intersect its axis are the vertices of the ellipse. We have it here a sample illustration representing a horizontal graph of an ellipse. As you can see here, the points are the vertices and two focus, and in plural, we call them foci. And here is the center, and this line, we can call this one as the focal axis because it's where we can locate the foci of the ellipse. So in this graph, we have point P, point F2, and point F1. By definition, it was mentioned there that the sum of D1 and D2 is a constant, which means this distance here from F1 to P, that's D1 or D sub 1, and the distance from P to F sub 2, labeled as D sub 2, the sum of these distances is a constant. Let's derive the equation of an ellipse. Given a graph here, so we have for point P, we label for its coordinates x and y, and for point F sub 2, we have the coordinates c and 0, and for F sub 1, we have the coordinates negative c and 0. Okay, we have something to notice. The Pythagorean theorem here is also applicable. We have b squared is equal to a squared minus c squared. Okay, so we derive the Pythagorean theorem and it turns out into b squared, which is equal to a squared minus c squared. An equation for the two dashed distances, okay, here we go. That's pf sub 1 plus pf sub 2 is equal to 2a. And using the distance formula, we are going to substitute there the coordinates of each given. So from P point P to F sub 1, so we have it here. That's the square root of x plus c quantity squared plus y minus 0 quantity squared plus the square root of x minus c quantity squared plus y minus 0 quantity squared, which is equal to 2a. So the pf sub 1 is this one, and then the pf sub 2 is this one. Next. Okay. So we need to apply the subtraction property of equality. This expression here is subtracted from the right or from 2a. We subtract it from 2a. So as you can see, it turns out this expression from the left, we are going to remain this one. So just copy this given below. So you have it here. And using the subtraction property of equality, this expression is now subtracted here. So we have 2a. So on the right side, we have 2a minus the square root of x plus c quantity squared plus y squared. Okay, let's observe why is it like that for the following given. Next, we need to cancel out the radical sign here on the left. And in doing so, we are going to raise it to the power of 2. So we square both sides of the equation. Since we square the left side, the radical sign now will be gone or will cancel with the power or with the exponent 2. Therefore, as you can see, this is a square of a binomial, so we apply it. So x squared for the first term, and then for the middle term, that's x times c times 2. So that's 2cx or 2xc. And then we follow the sign, which is negative. And for our third term, this is negative c squared, that is plus c squared. Plus copy y squared is equal to, we are also squaring our right side. So 2a squared, that's 4, or 2a quantity squared, that's 4a squared, minus the middle term. So this is also a binomial, 2a and this expression. So that's a binomial. So 2a times this expression here times 2, we get 4a square root of x plus c quantity squared plus y squared. And then we follow the sign, which is negative. So we write negative here. And for our third term, which is this whole expression, all we need to do is to cancel out the radical sign, and then we are going to perform here the operations. So this is a square of a binomial again. So that's x squared. And then the middle term is 2cx or 2xc plus c squared for the last term, and then bring down y squared or just copy y squared. Next, so we write it here, just the same. Then after that is to uh, cancel out. So before we arrive this answer, we need to cancel out x squared and x squared. We cancel out c squared and c squared, y squared and y squared. Yes. And then this expression here, the minus 4a times the square root of x plus c quantity squared plus y squared, we are going to apply addition property of equality. So we will add, that's plus 4a times the square root of x plus c quantity squared plus y squared. So that cancels out each other. And then since we add that expression on the right, so we will add that one also on the left. So as you can see, this one is the result because uh, from here, we have negative 2cx. We're going to add plus 2cx to our left, and we're going to add plus 2cx to our right. So this will turn out to 4cx because you're going to add them. So they are similar terms. And then 4a squared. So, sir, what happened to that one? So we divide the whole equation by 4. So we can see that the 4 here is gone. The 4 here is also gone, and the 4 here is also gone because it cancel out with the 4 or with the value 4. And this is now the remaining equation. Next, what are we going to do? We are going to square it again because we need to cancel out here the radical sign. So we need to square this expression and square this expression also. So we square both sides. Now the result in squaring both sides, we get a squared times the quantity of, so we are going to cancel out the radical sign. So it will turn out to x squared plus 2cx plus c squared plus y squared. And also here in our right side, we are squaring this binomial. So this will turn out to a square of a binomial. So a squared raised to the power of 2, that's a raised to the power of 4, plus the middle term, a squared times cx times 2, that's equal to 2a squared cx. And then for the last term, cx, and then you square it. So cx quantity squared, that's c squared x squared. And after that, you distribute your left side. So we get a squared x squared plus 2a squared cx plus a squared c squared plus a squared y squared, which is equal to a raised to the power of 4 plus 2a squared cx plus c squared x squared. So we are just bringing it down here. Our right side is still the same. And what do you think are we going to do next? So observing from this equation, as you can see, we cancel out 2a squared cx, 2a squared cx. We cancel them out. So the remaining expression will be a squared x squared, a squared c squared, a squared y squared, a raised to the power of 4 is equal to a raised to the power of 4 plus c squared x squared. The next step is we are going to regroup them. So you regroup a squared x squared. So you regroup it with this expression. So since it's in the right, so we need to subtract it on the left. So that's a squared x squared minus c squared x squared. And then you also regroup a squared c squared to our a raised to the power of 4. Then a squared y squared will remain in that position. So as you can see here, we are factoring out their common factor. So from after regrouping, you factor out x squared plus copy a squared y squared, which is equal to. So from the right, you regroup. Once you're done regrouping, you factor out a a squared, and then times the quantity of a squared minus c squared. Therefore, we can now proceed. So remember that I let you remember the thing and notify that b squared is equal to a squared minus c squared, right? From the start of this derivation. So basically, we are going to substitute that by b squared. So a squared minus c squared substituted by b squared. Same goes with the right side. A squared minus c squared will be substituted by b squared. And after that, we divide both sides by this one, which is a squared b squared. So we divided a squared b squared, and also from the left, divide a squared b squared. And it will turn out to x squared over a squared plus y squared over b squared, which is equal to 1. And this explains why is it the standard equation of the ellipse. So you might be wondering why is it 1? It's all because of this derivation here I've shown to you. Then this equation is the standard form of the equation of an ellipse centered at the origin with the x-axis as its focal axis. When the y-axis is the focal axis, how are we going to determine? It's very easy by observing the form of the standard equation. So if our a squared will be located on the denominator of our y squared, then we can say that the focal axis is located on the y-axis. So it's also quite opposite to our standard equation when the focal axis is at the x-axis, because a squared is the denominator of our x squared. So that's the x-axis as its focal axis. Then for our definition of terms, we have chord. It's a segment with endpoints on the ellipse. And for the major axis, it's the chord lying on the focal axis, which is equal to 2a. And for our minor axis, it's the chord through the center perpendicular to the focal axis, which is equal to 2b. The number A is the semi or semi-major axis, and the number B is the semi or semi-minor axis. Since we say that major axis is equal to 2A, so if you're going to divide it by 2, then the semi-major is A. Same goes with our minor axis, which is 2B. So when you divide it by 2, our semi-minor is B, is the number B. So let's have here an ellipsis with center at the origin. So we have the standard equation, and with whose focal axis is the x-axis. As you can see, the form, the standard equation that a squared is the denominator of our x squared, and we can say that the focal axis is located in our x-axis. And then for the form of our foci, that's positive negative c, comma 0. And for our vertices, that's positive negative a and 0. And for our semi or semi-major axis, that's still A. Same goes with semi-minor axis, that's B. And for the Pythagorean relation, we are still using A squared is equal to B squared plus C squared. Why is it like that, sir? Because this explains. Okay, we're using A squared. So this is our A here, and this is our B, then this is our C. So in order to find the value of A, we use the Pythagorean theorem since this forms a right triangle here. So, if you're asking, and if you were asking, sir, why did you label this one as A? Yes, this is labeled as A because this distance from this point to that point is just equal to A. Remember that our A is from the origin, A units to the right. That's our A. Yes, they are equal. Same goes with here to this. This is also A because it has a total length the same with the major axis, which is 2A. How about for the ellipses with the whose standard equation is y squared over a squared plus x squared over b squared is equal to 1. Okay, as you observe, the a squared is in the denominator of our y squared, then our focal axis is located in our y-axis. And for our foci, that's 0, positive, negative c. And for the vertices, that's 0, positive, negative a. And for our semi-major axis, it's just the same, which is a. Semi-minor axis, that's b. And Pythagorean relation, we're using the same a squared, which is equal to b squared plus c squared. And for the graph, it's now different. So it's a vertical graph. And this is now labeled as C, this is labeled as B, and then this is still labeled as A. So as you can see here, the points plotted, we have here the vertices, we have here the, this is co-vertices. So if you're referring to uh, the axis where we can locate our minor axis or semi-minor axis, we call them co-vertices. And this one is the vertices. This is our foci here. Let's try to illustrate some practice problems. Find the vertices and the foci of the ellipse of 4x squared plus 9y squared, which is equal to 36. How are you going to solve for that? First, write in standard form. Okay, take note for our standard form that the right side should be equal to 1. So you need to generate this one and situate this carefully. How will you make the right side be equal to 1? By dividing it by 36. So when you divide 36 on the right side, we also divide 36 on the left side. So after dividing, we will get x squared over 9 plus y squared over 4, which is equal to 1. Because the larger number is under the x term, the focal axis is the x-axis. So a squared is equal to 9, which is this one, and b squared is equal to 4. And we can find the c by using the Pythagorean relationship. That's c squared is equal to a squared minus b squared. So we substitute it there. 9 minus 4, so c squared is equal to 5. Then we have the vertices now. Positive, negative 3, because this is the value of a here. And for the foci, it's positive, negative square root of 5, then 0. Sir, why is it positive negative square root of 5? Because the value of c squared is 5. Therefore, the value of c is the square root of 5. So this is the graph of that standard equation. Okay, let's try another example. Find an equation of the ellipse with foci 0, -3, and 0, 3, whose minor axis has length 4. Sketch the ellipse and support your sketch with a grapher. Let's start. So we can say that the center is 0, 0. Mhm. And the foci are on the y-axis with c. So from the given here, from with c is equal to 3. And then the semi-minor axis is b is equal to 4, right? For the total length, this is the minor axis. And we're looking for the semi-minor. So we divide it by 2. The minor axis length will be divided by 2. We get 2. So b is equal to 2. So using the Pythagorean relationship to solve for a squared is equal to 2 squared plus 3 squared. That's a is equal to square root of 13. Next, now we have the value of a, the value of b, and then the value of c. We can substitute it now to our standard form. So starting with y squared all over a squared plus x squared all over b squared, which is equal to 1. Sir, how did you determine that it's in a form of y squared? So why is that the it's how did you determine that it's a vertical ellipse? Okay, by looking at your foci. Okay, look at your foci. So our value, the value of axis of the foci is 0, right? So we can say that the center is at 0, 0, but look at the value of y. That's -3 and 3. So take note that the foci lies in the major axis. So therefore, we can determine from this given that the graph is a vertical ellipse. So therefore, we have the standard equation y squared all over 13 plus x squared over 4 is equal to 1. Can we graph by hand? Yes, we can graph it. To check with a calculator, we solve for y. Y is equal to positive negative square root of 13 times 1 minus x squared all over 4. And then here is the graph. That's the graph of our equation. Next, what happens when the center of an ellipse is not on the origin? So if you're wondering, how about if it's not in the origin, what will happen? Okay, it's still very easy because it will look like this. So it's not in the origin. So with our center HK, with our foci H plus minus C and K, with our vertices H plus minus and K. Okay, and for our vertical ellipse, we have still HK, and it differs on the foci. So we have H, comma, K plus minus C. And for our vertices, that's H, comma, K plus minus A. Mhm. So, okay, let that. So you absorb it well, the properties. So let's explain the properties. Here we go. So for the standard equation of this form, where we locate the major axis in the denominator of our x minus h quantity squared, mhm, therefore we can say that the graph is in a horizontal ellipse. How about for the focal axis? So the focal axis is y is equal to k. Yes, take note for that one. This is a constant property, so it will never be changed. And for the foci, that's h plus minus c and k. For the vertices, we have h plus minus a and k. And for the semi-major axis, that's a. And for the semi-minor axis, that's b. And Pythagorean relationship, we use a squared is equal to b squared plus c squared. How about if the, okay, if our major Okay, by observing the standard equation or the standard form, so we can see a squared is located in the denominator of y minus k quantity squared. Therefore, we can say that the graph is in a vertical ellipse. So we have here the properties below. So all of these properties here below are constant. So for the focal axis, it will always be x is equal to h. And for the foci, that's h comma k plus minus c. And for the vertices, that's h comma k plus minus a. For the semi-major axis, it's still a. Semi-minor axis, that's a b. And Pythagorean relationship, that's a squared is equal to b squared plus c squared. Let's have a guided practice. So let's try to solve. Find the standard form of the equation for the ellipse whose major axis has endpoints -2, -1, and 8, -1, and whose minor axis has length 8. Okay, take note for the given. We have there the endpoints of the major axis, and then the minor axis has length 8. So what are you going to do? So first, how about starting with the diagram of the given info? Is it possible to start with this with a diagram? Yes, it's possible to start with a diagram. As you can see, those are coordinates for the endpoints, and we have the length 8, so you can plot them. And if you don't like to plot them, it's still okay. We can still solve for that by observing the given. What is the general equation? I can say that the general equation is in a form y minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. Why? How did you determine, sir, that the standard equation will be like that? Okay, let me tell you here. Observe the value of our y's from the endpoints. As you can see, they are the same, right? Mm-hmm. So this is the major axis, right? So from the properties shown before, so we can say that the value of k, if the graph is in a horizontal graph, will never be changed for the endpoints of a major axis. So they have the same value for k here. Mhm. Now, where is the center or the midpoint? Okay, by using the midpoint formula, basing from the endpoints of our major axis, we can solve it. The hk is equal to 3 and -1. So actually, the k is already given here. Mhm. If you can observe that from the properties of the horizontal ellipse. Therefore, or you can use the midpoint formula. And therefore, the value of our h and k is 3 and -1. Okay, since we have already 3 and -1, and then we have the guide of the standard equation, now find the semi-major and semi-minor axis. Yes, we can find it. First, the semi-major axis by using the value of our axis here in the endpoints of our major axis. How? How are we going to solve for that, sir? A is equal to 8, the value of our x sub 2, minus, so that's x sub 2 minus x sub 1 all over 2. So that's the value of A. So we have it here. Basing from the major axis, okay? So 8 minus -2 all over 2, that's equal to 5. So we have now the value of A, which is 5. And for the value of B, we have already here the length 8. So we only divide it by 2 to find the semi-minor axis, which is 4. Okay, we already have A and B, therefore we can plug all of these values back into our general equation. Okay, we have it here. That's quantity x minus 3 quantity squared all over 25 plus y plus 1 quantity squared over 16 plus 1 for the standard form. So we're looking here for the standard form. And that's the answer. How about the graph, sir? Okay, here is the graph of that standard equation. So it's really a horizontal graph. with center 3, negative 1. So the green there is the focal axis, where we can locate the foci of the ellipse. Now for your whiteboard practice, please answer this one. Find the center, vertices, and foci of the ellipse with this given. Here is the answer. For the standard form, mhm, and for the center, that's negative 2 and 5. For the vertices, that's negative 2, 5 plus negative 7, which is equal to negative 2, 12, then negative 2, and negative 2, negative 2. And how about the foci? We need to find first the value of c before you can solve for that. And once you get the value of c, you can now substitute there the value of c. So the foci is negative 2, comma 11.325 and negative 2, comma negative 1.325. So I hope you get the correct answer. And this is the graph of that equation. So amazing. Let's have another example. Find an equation in standard form for the ellipse that satisfies the given conditions, whose major axis and points are given, and the minor axis length, which is 4. Here is the answer. For the center, it's negative 2, 2. For the semi-major and semi-minor axis, or the value of A and B, that is 5, B is 2. And for the standard form, you get y minus 2 quantity squared over 25 plus x plus 2 quantity squared over 4 is equal to 1. And this is the graph. Okay, let's have another one. Find an equation in standard form for the ellipse that satisfies the given conditions. The foci are negative 2, 1 and negative 2, 5. The major axis endpoints are negative 2, negative 1 and negative 2, 7. Let's present the answer. Start with a diagram if you want to. So we can determine the center, determining the center that's negative 2 and 3. The semi-major axis or the value of A, that is 4. Semi-minor axis or the value of B, we use that formula, which is equal to square root of 12. And for the standard form, it looks like this. Congratulations to those who got the correct answer. And this is the end of our lesson, which talks about ellipse. Thank you so much for watching and listening to my video. See you.